రెస్పాన్సివ్ అవ్వట్లేదు. నేను హర్ట్ అయ్యాను. నాకు ఇప్పుడు హర్ట్ అయ్యి వేస్తే ఇప్పుడు వెళ్ళిపోను, ఇప్పుడు క్లాస్ చెప్పేసి వెళ్ళిపోతా. రైట్. Yeah. Yesterday, just let me review what we have discussed yesterday's class. In yesterday's class, we have started compilers and we have discussed some basics of the compilers. We have understood what is a compiler. What is a compiler? Very good. Source language to object language. What are the object languages? Assembly language program, relocatable machine code, and absolute machine code. 3 types. Fine? Okay. Done. And then we have discussed how language processing system works. What is required, what we are going to write? We are writing the source program. And what we are going to have, we need to have absolute machine code. Right? That means we write source program. What machine requires? Absolute machine program. In the process of converting source program to absolute machine program, is only compiler is sufficient? No. In addition to compiler, we also require preprocessors, assemblers, linkers, and loaders. What is this? Also we have discussed. And we have seen the history about a compiler, and also the task of compiler is also done by another language processing system called interpreter. What is interpreter? ఇప్పుడు లైన్ అనేది ఎట్లా కొడతాను. It is a language translator which translates either language programming to machine language and interprets each instruction, which one instruction by one instruction it executes it immediately against the data. Means interpreter will take input source program and out and also data and gives you output. So compiler will give you object program. Interpreter give you output of the program. Okay. And even Java language processing system, we have seen how this is going to be implemented. And we have started compilation phases. Okay, bootstrapping. Okay, the differences we have seen between compiler and interpreter, and we have discussed a concept called bootstrapping. What is the bootstrapping? So it is a process of compiling a compiler program in its own language to get a compiler for new programming language. Means using one language, we have to generate a compiler for new language using bootstrapping process. This one we have discussed, and I said it is important for your two exams. And then logical phases of a compiler. Compilation phases are divided into 2 parts. We call analysis part and synthesis part. In the analysis part, we have certain tasks. And in the synthesis part, we have 2 tasks. Each task is represented as one phase in the compiler. What is phase? It is a logically interrelated operation. How many phases we have in the analysis part? 5 phases. Lexical analysis, syntax analysis, semantic analysis, intermediate code generation, machine independent code optimization. This is completely called front end of the compiler. And then this is code generation and machine dependent code optimization. We have seen phases, and there are 5 phases in the analysis part and 2 phases in the synthesis part. Now here, the point is the analysis part and synthesis part is separated. Why it is separated? ఎందుకు separate చేయాల్సిన అవసరం వచ్చింది? Separate చేయడం వల్ల ఏంటి మనకి? And why I am calling the compilation process 2 parts, analysis part, synthesis part? ఎందుకు అంటున్నా? ఎందుకు 2 parts కింద డివైడ్ చేస్తాం? ఎందుకన్నిటికీ ఒకటి పార్ట్ అనొచ్చు కదా? So what is the benefit of separation of front end with back end? ఎందుకు చెప్పండి? ఎందుకు చెప్పండి? పర్లేదు. Whatever you think. Why? analysis part and synthesis part is to be separated. ఎందుకు సపరేట్ చేయాలి? సపరేట్ చేస్తే వచ్చే బెనిఫిట్ ఏంటి? సపరేట్ చేయకపోతే ఏమవుతుంది? సపరేట్ చేయకపోతే ఏమవుతుంది? రైట్, ఒక్కరికి చెప్పాను. సరే చెప్పండి, నేనే చెప్పాలా? లేదు మీరే చెప్పాలి, చెప్పండి. See, we have a compiler for a programming language. ఒక P programming language, ఒక compiler ఉంది. So this P programming language, we have to give it to the front end of the compiler. Okay, front end is what? Analysis. Then it is going to generate which code? Some intermediate code. Right now, what is the output of analysis part? Intermediate code or it's optimized code? We can call intermediate code, it is giving. Now this intermediate code is platform independent or dependent? Is it depending on the machine or independent on the machine? Independent on the machine. It is independent on the machine. It is machine independent, not dependent. Right? It is machine independent. Because it is machine independent, suppose I wanted to have a compiler for some new machine, some machine I wanted. So what I have to write? I have to write a backend program for a particular machine. Now this backend program will take intermediate code and generates a compiler for that particular machine. We can call it compiler for that particular machine. Suppose if you wanted to generate a compiler for one more machine, information compiler cover. So what we have to do? Is it required to write both front and back end? రెండు రాయాలా? ఫ్రంట్ ఎండ్ బ్యాక్ ఎండ్ చెప్పండి. రెండు రాయాలా? ఓన్లీ బ్యాక్ ఎండ్ రాస్తే సరిపోతుందా? సో వాట్ వి కెన్ డూ, వి రైట్ బ్యాక్ ఎండ్ 2 and this back end 2 will take the intermediate code and generate a compiler for machine 2. Suppose if I wanted a compiler for machine 3, what is to be changed? Only back end is to be changed, not the front. It means front end is completely dependent on the programming language, not depending on the machine. So, because which is depending on the machine, back end is depending on the machine. So that if I want to generate a compiler for any new machine, the first 5 phases are same. Because first 5 phases are same, it is not required to rewrite the program of front end. You have to only rewrite the program of back end. So that generating a compiler for new machine is easy. This is the benefit of separating front end with back end. అంటే నేను ఏదైనా కంపైలర్ కొత్త మిషన్కి రాయాలంటే మళ్ళీ మొదటి నుంచి రాయాల్సి పర్లేదు, లాస్ట్ 20 ఫేసెస్ రాసిస్తే సరిపోతుంది. This is called retargeting is facilitated, which a compiler for new machine can be easily created. We can create easily. And this is the logic followed in the Java compilation process. In Java compilation process, analysis part and synthesis part are separated. See, the front end is implemented by Java C. Back end is implemented by Java virtual machine. So front end is gives you intermediate code. That intermediate code we call bytecode. And this bytecode is given to the Java virtual machine, back end, so that it is going to give you the output. So because of separation of front end with back end, separate JSON, so that the Java becomes platform independent language. Are you getting my point? This is makes the Java is a platform independent language. Otherwise Java is dependent because it is separated front end part and back end part, so that it is generating an output for any machine. So what I said, if your program is to be executed for after 100 years on a new processor, what is to be changed? Only JVM it requires to be changed. Means only backend is to be changed. Front end we need not to disturb. This is the purpose of separating front end with backend. Is it clear? Right. Now, in this phase of compiler, first we have started our discussion with lexical analysis phase. In the lexical analysis phase, it is going to divide the program into pieces called tokens by scanning the program from left to right. Right now, what is a token? The token is a class of lexemes. What is a lexeme? It is
What is a lexeme? A logical unit of a program. How this is going to be identified based on the pattern. Pattern specifies rule that describing the token. And class of lexemes is called tokens. And what it will do, it is going to scan the input from left to right and identifies the token. Identifies the tokens. Identifies the lexemes like let us say total is lexeme, sub1 is lexeme, sub2 is lexeme. And these are all the similar class of lexemes of type called identifier. I can call identifier as a token, right? We call identifier as a token. Now look at it. And how these tokens are to be identified based on the input buffering concept. In the input buffering concept, it uses 2 pointers. One is begin and one more is forward pointer. And forward pointer always check for the next character for testing the pattern. If a pattern is not matching, then it stops. Like after it reaches the equal symbol, it is stopping. Then because after like whenever total TOTAL is there, so every time it is matching with the pattern of token, identifies. Whenever it is equal, stops. So because pointer is forward enough, so that it will move one step backward and conclude begin to forward is a one lexeme. And that lexeme, class of lexeme is called one token. Later again what it will do, this content forward and begin will point to the next input later. Means again it will make a forward. And so that it will identify all the tokens. And these tokens are to be grouped according to the syntactic structures. So syntax of a programming language is represented using a grammar. Using grammar. What type of grammar used by the programming languages? Context-free grammar. So using this grammar, these tokens are grouped into syntactic structures. That grouping is represented in the form of tree. That tree is called parse tree. Another representation is called syntax tree. Syntax tree is called condensed form of parse tree or compressed form of parse tree, where internal nodes representing the operators, leaf nodes representing the operands. Okay, this is a parse tree. Now this parse tree or syntax tree will be given as input to the next phase of the compiler. So what is the next phase of the compiler? Semantic analysis phase. I think yesterday we have discussed up to syntax analysis. Sure, next. Go ahead with this. Semantic analysis phase. Semantic analysis phase. Semantic analysis phase. Write down. Right now, it checks the source program for semantic errors. Checks the source program for semantic errors. And one of the important components of semantic analysis is called type checking. We can call type checking is one of the important components of semantic analysis. What type checking will do? It is going to check the type of the operators for the operands. Means is it according to the programming language specifications? And I will explain. First you write the sentence for the sake of your notes. It checks the source program for semantic errors. An important component of semantic analysis is